Hello, in this video we're going to look at a utility function with perfect substitutes, and we're going to look at three measures of consumer welfare: compensating variation, equivalent variation, and consumer surplus. Here's our perfect substitutes utility function. Income is $12, price of good Y $2, price of good X $1, forming the budget constraint, 12 equals X plus Y. Again, we're going to calculate the compensating variation, equivalent variation, and change in consumer surplus from an increase in the price of good X from $1 to $1.50. Before the price increase, the marginal utility of good X divided by the price of good X exceeds the marginal utility per dollar of good Y. The marginal utility of good X is just a coefficient on X, that's 4. Dividing it by 1, the price of good X, that'll exceed the marginal utility of good Y divided by the price of good Y. So in this case, the consumer will buy nothing but good X because it provides more marginal utility per dollar. After the price increase, the same thing. It'll still be the case that the marginal utility per dollar of good X exceeds the marginal utility per dollar of good Y. The consumer is still getting more bang from the buck by buying units of good X. So the consumer spends all income on good X before and after the price increase. So Y equals 0 before and after the price increase. So first we're going to calculate the compensating variation, the amount of money to give to the consumer to completely offset the price increase so the consumer's utility is unchanged. So here's our utility function. Here's our budget constraint. And as we said, the consumer will buy nothing but good X, so Y is 0. That means the consumer will spend his or her $12 on good X, and therefore the consumer will buy 12 units of good X. The price of good X right now is $1. The consumer's utility from buying 12 units of good X and 0 units of good Y is 48. Just plugging those values into the utility function. So now we're going to set utility equal to 48. And again, Y is 0. The consumer is not spending any of his or her income on good Y. So 48 equals 4X. Solving for X, X equals 12. And now we're going to evaluate this at the new budget constraint. The new budget constraint takes into account that the price of good X is now $1.50. So we're going to have M equals 1.5x plus 2y. Y is 0, X is 12, and M is $18. So what does this mean? It means that the compensating variation here is 18 minus 12, or $6. The combination of an income of $18, the price of good X of $1.50, the price of good Y at $2 gives just as much utility as our original situation where the consumer only had $12 of income and the price of good X was $1 and the price of good Y was $2. So again, the compensating variation is the amount of money to give to the consumer to completely offset the price increase. So that would be $6. The consumer would need $6 more to maintain the same level of utility given the price increase of good X from $1 to $1.50. Now let's look at the equivalent variation, the amount of money a consumer would be willing to give up in order to not face the price increase. So another measure of consumer welfare. I'm going to start it like this. Start with our utility function. The budget constraint now is going to be, we're going to start with the higher price for good X. So 12 equals 1.5x plus 2y. As we said, the consumer still will not buy any units of good Y even at this higher price. So 12 divided by 1.5 means X is 8. Evaluating our utility function at 8 units of good X, 0 units of good Y, utility is 32. So setting utility equal to 32, our utility function equal to 32, setting Y equal to 0, solving for X, X equals 8. And now we're going to evaluate our budget constraint with the original price of the good X. So M equals X plus 2Y. X is 8. as we just solved for. Y is 0, so that means income equals 8 or $8. So the equivalent variation here is going to be the difference in income, 12 minus 8, or $4. So this consumer would be willing to pay $4 to avoid facing the price increase. So again, the combination of $12, the higher price of good X, and the price of good Y at $2 gives just as much utility as the combination of only $8 of income, price of good X at its original price of $1, and the price of good Y still at $2. And now let's look at the change in consumer surplus, our last measure of consumer welfare from the price increase. So first we have to get the demand for good X, and we're going to get that from the budget constraint. So here's our budget constraint. I'm not plugging any values in for the prices here. We do know that Y is 0 in our example. So if Y is 0 and solving for X, we have our demand for good X. X equals the income 12 divided by the price of good X. As the price of good X rises from $1 to $1.50, the change in consumer surplus will be the following. So now we need to do a little integral calculus here, the change in consumer surplus. Since the price of the good is going up, we're going to have a reduction in consumer surplus, so that's why the minus is out here. And so we take the integral of 12 divided by the price of good X, and here's the rule down here. You're going to just get minus 12, the natural log of X, bringing that minus in front here. And so integrating over this range of the demand curve, we get a reduction in consumer surplus here of $4.87. So the three measures of consumer welfare, just to summarize here, we're dealing with a normal good, so the welfare effect of a price change dealing with a normal good. The compensating variation in absolute value will exceed the change in consumer surplus, which will then exceed the change in the equivalent variation. So the compensating variation was $6, the change in consumer surplus 4.87, and the equivalent variation was $4. All right, that's it. I hope you found this video helpful.